Good morning, students. Today's topic is ammonia. Its preparation, properties and the different uses are discussing in this topic. Okay. First, ammonia is mainly present in small quantities in air and soil, and it is formed by the decay of nitrogenous organic fertilizers or organic compounds. Okay. Nitrogenous organic compounds. Decay of nitrogenous organic compounds. Example is urea, that is NH2, CONH2 on decay. It gets converted into ammonium carbonate, okay, from which we can obtain ammonia to NH3. Ammonia can be obtained plus H2O plus CO2. Okay, this is the reaction. Now, small scale preparation. Small scale, it can be prepared from ammonium salts. Ammonium salts like this ammonium chloride, then ammonium sulfate. This ammonium chloride and ammonium sulfate on decomposition with caustic soda and lime. First, ammonium chloride. Ammonium chloride on reaction with lime, CaOH twice. By this process, ammonia is obtained plus H2O plus CaCO2. Okay. Next, from ammonium sulfate with caustic soda. We can obtain ammonia to NH3 plus 2H2O plus Na2SO. Okay, these are the small scale preparation from ammonium salts, ammonium chloride and ammonium sulfate. Next is large scale preparation. Large scale, it can be prepared by the process called Haber's process. It is given here. Now let us discuss that. So large scale preparation by the process called Haber's process. So in this process, nitrogen and hydrogen passes through this inlet. So nitrogen and hydrogen on reaction at certain optimum conditions, ammonia can be obtained. Okay, and the reaction is as follows: N2 plus 3H2 gives 2NH3. So we can obtain ammonia. Okay, and in this process, the energy released, that is enthalpy of fusion, is minus 46.1 kilojoule mole inverse. This much energy is released during this process. Okay, so nitrogen and hydrogen is passed through this inlet, and the conditions are at high pressure. At high pressure of about 200 atmospheric pressure and a temperature at a high temperature of 700 Kelvin, the reaction is taking place. This is important, at high pressure and temperature. And the catalyst present are iron oxide. Iron oxide with a small amounts of potassium oxide, K2O and Al2O3. Okay, so H2 and N2 comes through this outlet. This inlet then reaches the compressor. Then it is passed through the catalyst, iron oxide, in presence of Al2O3 and K2O3 at a temperature of 700 Kelvin and at a high pressure of 200 atmospheric pressure. The products obtained are N2, H2 and ammonia will come through this pipe and reaches here. And from here, liquid ammonia is collected at the bottom, and nitrogen and hydrogen gas is moves up And it again, the process continues, reaches to the pump, then it again comes to the, reacts with the catalyst, then again the process continues. This is the process. So the conditions are very, very important. At high pressure of 200 atmospheric pressure and temperature 700 Kelvin, and this much energy is released, and in presence of a catalyst called iron oxide. Okay, and this process is called as Haber's process. This is a large scale preparation of ammonia. Now, next, properties. So, physical properties. First point, it is a colorless, pungent smelling gas. Colorless and pungent smelling gas. And its melting point and boiling point are very high due to its particular molecular structure. That is, freezing point is about 198.4 Kelvin and boiling point 239.7 Kelvin. Okay. Now, next, in its solid and liquid state, it is associated through hydrogen bond, because NH3 is the molecular formula. It contains hydrogen atoms. So, in solid and liquid state, it's associated through hydrogen bond. And its high melting point and boiling point is due to its particular molecular structure. Now, what is the molecular structure? It has a trigonal pyramidal shape. Trigonal pyramidal shape. And see the structure. Nitrogen is at the apex and it contains 3 bond pairs. And 3 NH bonds are present, and there is a lone pair of electrons. These lone pairs are responsible for the Lewis base structure. Okay, due to the presence of this lone pair, it acts as a Lewis base. Okay, and now 101.7 pm is the bond length, and this bond angle is 107.8 degree. This is the bond angle, and structure is trigonal pyramidal shape. It contains three bond pairs and 1 lone pair, and due to this structure it has very high freezing point and boiling point. Okay, next, chemical properties. Chemical properties of ammonia. What are the chemical properties? It is highly soluble in water, and with water it produces OH minus ions. Due to the presence of this OH minus ion, it is weakly basic. So, highly soluble in water, highly soluble in water, ammonia. Ammonia on reaction with water. NH4 plus ammonium salt and OH minus. Ammonium ion and OH minus ions are obtained. Due to the presence of this OH minus ion, it is weakly basic. Okay, weakly basic. Now, it also reacts with acids like HCl and H2SO4 and form ammonium chloride and ammonium sulfate are obtained. Ammonium chloride and also forms ammonium sulfate with HCl. With acids, it produces ammonium acids, ammonium salts like ammonium chloride and ammonium sulfate. Next, due to the presence of lone pair of electrons present in ammonia, it acts as a weak Lewis base. Weak Lewis base. It acts as a weak Lewis base due to the presence of lone pair of electron, and it precipitates hydroxides of many metals from their salt solution. Okay, forms hydroxides. Examples: FeCl3. FeCl3 with its hydroxide like ammonium hydroxide. Ammonium hydroxide. It produces Fe2O3xH2. It's a brown precipitate. So precipitates are obtained. So these metals gets precipitated. Okay, iron gets precipitated as iron oxide. Okay, and it is brown in color, and plus 3 NH4Cl. Okay, next, what about zinc sulfate? Zinc sulfate also with NH4OH, ammonium hydroxide. It produces zinc hydroxide. Zinc hydroxide is obtained, which is a white precipitate. So white precipitate is obtained with hydroxides, ammonium hydroxide. These metals produces, there gets precipitated, and plus NH4 twice SO4. Okay, so these are the hydroxides, hydroxide precipitation of hydroxides. Next, fourth point, due to the presence of lone pair, it acts as a Lewis base. So this nitrogen can donate its lone pair and forms linkage with certain metal ions, and which helps the detection of metal ions. Okay, lone pair in nitrogen forms linkage with certain metal ions, and which helps to the detection of these metal ions. Okay, like Cu2 plus and Ag plus. Okay, reaction Cu2 plus. This is blue in color. Okay, this on reaction with ammonia, 4NH3. What happens? The color changes due to the formation of a complex, because the lone pair present in nitrogen forms a linkage with Cu2 plus ion. Cu NH3 4 times 2 plus. A complex is obtained. This is deep blue in color. Okay, so the color changes. So this helps to detect Cu2 plus ion. Next example, AgCl. This is a white precipitate. It becomes colorless with ammonia. With ammonia, it forms a complex Ag NH3 twice Cl. Okay, this is colorless. Okay, so these are the different chemical properties of ammonia. Next, let us discuss the uses. Uses of ammonia. What are the uses? First point, it is used to produce various nitrogenous fertilizers. Produce nitrogenous fertilizers. Examples are urea, then ammonium sulfate, ammonium nitrate, then ammonium phosphate, etc. Ammonium nitrate, ammonium phosphate, then ammonium sulfate. These are examples. Now, next point, it is used in the manufacture of certain inorganic nitrogen compounds. Manufacture of inorganic nitrogen compounds. Example, nitric acid. Example, nitric acid. Next, third point. It is also used as a liquid ammonia is used as a refrigerant. Liquid ammonia used as a refrigerant. Okay, these are the important uses of ammonia.